Thank you very much. Follow me there. Mirdita. Mirdita, did I say that right? Yeah, Sieni. Awesome. Well, thank you so much. This is SkyScalpel, and we'll be talking about some fun obfuscation related to cloud policies and the like. Unchuhem Daniel Bohannon. I'm a principal threat researcher at Permiso Security, where we do cloud and identity detection and some really fun engineering and research. I've spent my career solely on the defensive side, doing an incident response, detection engineering, and now research in areas of obfuscation and evasion, which this research has a lot to do with. I'm a big fan of open source tools and coffee, and again, it's been really nice meeting a lot of you in this room yesterday, and so hopefully you find this interesting. And yeah, that's enough said about me. Feel free to call me Debo for short. That's what most people call me by.
Hello, everyone. My name is Abian Morina. I'm a threat researcher over at Permiso for over probably 2 years now. You can see my blogs over at Abian Morina at Permiso website. I've been over doing threat detection lately over at Permiso. I've been presenting recently. My first year presenting was last year. I was over at SANS, Blue Team Con, and 3 Black Hats. And this is our first open source tool that we released together with Debo, which was my manager. So
yeah, let's talk about it. We'll keep the intros pretty short to the problem, and then spend most of the time looking at some fun obfuscation, and should have a lot of fun. So sometimes people ask us, what's your research process? How did you end up at this kind of weird place? And it really depends. Every research is different. Sometimes it truly does have a very clear starting point, and you have the destination in mind, and it's a pretty straight path to get there. This was nothing like that. This was a really winding road, and every finding that we found was honestly not that interesting by itself. But when you start to piece all of these things together, it actually adds up to something quite interesting. And so we're going to share kind of all the building blocks. In this case, most of the building blocks had their greatest effect in the context of cloud logs. So at Permiso, we're doing cloud research and detection and investigation. And so we live and breathe by event logs, runtime logs, API logs. And so the interesting thing here is that when it comes to logging, unless you're the developer writing the logs, the consumer just has to kind of deal with whatever the logs look like. You're beholden to whatever the vendor produces in the logs, and those vendors are also humans. Humans make mistakes, and logs are not perfect. And so oftentimes we find logging inconsistencies and even errors or omissions where something should be there and is not, or a Boolean says it's true, but it's actually false. And so we have to deal with all of these from an engineering perspective with our engineering team. But what's really cool is from a research perspective, what are the logging inconsistencies that no one has found yet, or that people haven't talked about yet? How does that affect us when we're trying to detect malicious activity? And then how might that affect an attacker who wants to use that inconsistency to evade simple detections? So we'll be talking about some of the syntactical obfuscation of JSON at a really generic level, because a lot of cloud policy documents are in the JSON notation or format. And then we're going to talk about some really interesting quirks of JSON, some of the complexities around cloud policy evaluation, which is a really, really deep topic, and then we'll look at not only syntactical but also logical obfuscation of these policies. So for anybody who's in the room who has never done anything with cloud, I think you will find a lot of value out of some of the JSON, SOL JSON tricks that we'll be talking about. And so hopefully you'll find that interesting. And if anyone in here has done a lot of really cool work with JSON, we know you have stuff to teach us, and so we'd love to talk with you afterwards and hear what tips or tricks you'd have that you didn't see us talk about. So we're going to talk about these little tips and tricks in isolation, but more importantly, we're going to show how stacking these things together can produce some really nice evasive qualities when it comes to the area of cloud security policies. So with that, let's dive in. Let's talk about these building blocks as well as the kind of recipes of how we combine these to get different evasive qualities.
So when we wanted to show you about the RFC, about JSON history and formatting, we thought of reading all the 16 pages of RFC format here on stage, but that was a long list. So we thought of doing a Google Notebook LM to hold a podcast for us. But then also I thought we can just maybe show you because it's easier. So JSON allows Unicode encoding. If we can see here for the country Kosovo, the letter which is E with 2 dots, it does escape handling for escape non-ASCII characters. But that's not just for that. You can do that in JSON in both the values and the properties of the JSON, as we can see over there. Besides that, there's also insignificant whitespace. Now, for insignificant whitespace, there's space, horizontal type, line feed or new line, and there's carriage return. So, focusing on just those two, Unicode encoding and insignificant whitespace, a simple policy like that one can look into something like this. Yeah, that's pretty crazy, but Unicode encoded can be decoded, and insignificant whitespace is insignificant. So that can be removed. But something that I want you guys to pay attention at is this last one, the carriage return. Now, I'm going to take an example, catting 3 different JSONs, and by just looking at these JSONs, which one of these guys do you think is the evil policy? So what are these JSON doing? At the first one, we see that is allowing IAM list users, so probably listing some users. The second one is doing allow S3 list buckets, so probably just listing buckets. And the third one is just doing deny and action all. So if you thought that all of these are malicious, then you were correct. So we can see at the first one, if we hit the pipe JQ into it, we can see that it was hiding 2 action, IAM PassRole and EC2 run instances, which is used for privilege escalation vulnerability from RhinoSec. The second one, we can see that there's a full hidden statement hidden at the JSON. And at the third one, we can see that it was denying a decoy action. So it was denying something else, and it's actually allowing everything. So if we pipe JQ, how this happened? So this is because of the carriage return. If placed correctly, the carriage return will put the text that was written and overwrite it, so you won't be able to see it. As we can see, highlighted in yellow, we can see how it was placed and it's removed, and you couldn't see it. Now there's another case. We're doing the same JSON but using JQ, and we can see that it's saying name, benign example, meaning nothing to see here, and score 0. This is where another thing shows up, the duplicate properties. As we can see, there's more. So without the JQ, so before we did JQ, now we're doing just catting the JSON. We can see that there's more at the JSON. We can see that there's 2 names, there's 2 meanings, and there is 5 scores. Now, if we check over at the questions about does this allow it, we can see that in short answer is yes, but it's not recommended. And we can see that the names within an object should be unique. So it doesn't take a hard stance on being different. But also it says, in other words, if they're the same values in the same key, the last value wins. So we can see the last one that was written, it will be shown at the JSON. Okay, so what did we get from this? There are some uncommon rendering tricks when it comes to JSON, but what's important is the context, and the truth is dependent on specific tooling that we use. So we saw the cat and the JQ. So it's important to validate the findings in multiple ways. But where else can these tricks really affect us? So that's where the problems of obfuscating JSON really show up.
Yeah, so if we think about all these are generic to JSON, as Abian just looked at the RFC, and these are all things that are explicitly defined and allowed, or pseudo not recommended in the case that he just covered. So if these apply to any JSON document, then how does that affect me and my job, you know? So when it comes to cloud, there are many different places where you'll find JSON. So we'll just give a couple examples here. I think specific examples are helpful, especially when it starts to look pretty crazy with all this obfuscation. So we'll start with something sane. AWS SSM documents, when you're doing run commands, to basically issue commands on remote systems that are part of this SSM service, uses a JSON document. If you are using CloudFormation, again, kind of think of it like Terraform, like infrastructure as code, and you can define all these things as JSON blocks. And this one even has JSON within JSON. It has an embedded IAM policy. So these are just 3 quick examples of, yes, JSON is used often in cloud. And in fact, these aren't just random examples. These are examples of things that are part of known offensive attack tools that are open source, like Pacu from RhinoSec or CloudFox from BishopFox. And in fact, these aren't just a couple of random tools, like these are ones that we actually see in the wild. Right at a year ago, there's a really nice blog post by the Invictus IR team based out of Amsterdam. The blog post is called The Curious Case of Danger Dev Proton Mail. And it was really neat because it was a really nice blog post, and there's a guy named Nick Frechette who works as a researcher working at Datadog, and he had a really nice Twitter thread about all the interesting novel things he found in this cloud attack that Invictus posted. And so our team was going through a little exercise of hunting, and we actually discovered that this attack was actually from a known tool. In fact, it was this CloudFox tool. And so we tweeted a little something out and had this nice exchange of, yeah, look at the ordering of these API calls, look at the ordering in the JSON syntax of the policy in this command. It lines up exactly with what we see in the source code. Even seeing a year before that, there had been a couple updates to that source code. So it's really cool. We're huge fans of open source tools, and especially as defenders, we should take the time to hang out with the red teamers, to learn the tools they use, and to take advantage of the open source tools that are out there. And if we're actually really, really kind and smart, we would hang out and exchange those ideas back with the red team and say, hey, how would you evade this detection that we have? Evan, I appreciate you because we did that quite a lot back in the day, and it really helps refine red and blue together. So hopefully, I don't know, that's a whole separate conversation, but I hope that's a good takeaway. There's a lot that we can learn from each other in exchanging those ideas. So basically, when we got to this point, Abian and I realized, you know what, let's just take a policy and let's just poke at it. In fact, this was our internal code name for the project before SkyScalpel was just policy poking. Let's poke at it. Does it still work? Because we can change a couple of things and it looks different, but if it still functions the same, then we're getting some good evasive qualities. So how did we go about poking at policies? Well, if we're targeting an AWS policy, let's go to AWS into the actual policy builder. So here's an example of us building a pretty simple policy that allows these sets of actions, and we have 5 actions here. You'll notice the one that's highlighted is actually just nonsense. It's not a real action. So this is helpful to understand, can you create policies that contain nonsense? And you actually can. Sometimes the UI prevents you from doing some things, but allows you to do others. In this case, it allows us to create this policy. Now, this is the default view, which is JSON. And if you notice, there's a nice visual button there. If we were to click that, it actually groups all of the actions by their service. So the service name is the first prefix. IAM is the service, : and then the API name. However, when we did this, we realized it actually grouped the IAM service into 3 tabs, which is kind of weird. The whole point of grouping is to make it a little more concise, right? So if we expand the first one, we see, okay, this is this looks normal, it makes sense, it's showing us one of the actions from IAM is specified. But if we click the other 2, they actually show an error. It says, hey, we don't even recognize this action. Which is weird because when we looked at it before, it had no problem recognizing that action. And what we realized was this grouping in the UI is actually case-sensitive grouping because this IAM is all uppercase. This one has an uppercase A, and the previous one was all lowercase. So even in the UI now we realize, okay, some of their validation is case-sensitive, some is case-insensitive. What's actually true? We're trying to ask the product, teach us what's true and what's possible, and it's kind of giving us conflicting answers. And so in this case, again, it comes down to correct casing versus incorrect casing. So if we were to say, okay, AWS, you say this is incorrect casing and you don't know what this is, this action totally exists. You already told us that in the JSON view. Let's click on edit and see where we go from here. So if we click on edit here, it's going to say, hey, we don't recognize this action. Might be a typo, blah, blah, blah. Okay, we quickly see it's probably a casing issue. Let's change that A and P to lowercase. Or let's actually change it to a single character wildcard. And here is where we see another bit of information, which says, hey, the action names must be 2 to 64 characters and contain only alphanumerics or the asterisk wildcard. Okay, so single character wildcards aren't a thing. Got it. Thanks. So let's replace that then. Let's replace those characters with wildcards. Perfect. Now it's happy. It says this matches one action. You're good to go. Perfect. So mission accomplished. It already told us alphanumerics wildcards are the only thing that's allowed. Yeah, it's a little flaky on not fully understanding casing, but we know that casing is not sensitive because we can test this policy and see that we have the right access. Then, a month before we finalized this research, a familiar name, Nick Frechette, tweeted this little gem. And he said, hey, Monday Night Trivia, what actions does this policy permit? And he has loaded it with a familiar service name, IAM, and then, what is that, nine question marks. And I thought, what a troll, this guy's awesome. Obviously, it's an invalid policy because question marks aren't allowed. And immediately, Twitter responded, as Twitter responds, with a classic Simpsons gif. But then when the more serious answers came in, people were saying, is it everything? Is it these specific ones? Is it all 9? They're counting these things. And then finally someone got the right answer, which is none. Like, it's like, cool, somebody gets it. But then right after that, someone else just says, Nick, no, don't do this. Don't do this to us, man. And this is when we thought, like, did we miss something? Like, I swear, I know that AWS literally told us it's alphanumeric or wildcards. And so one of our other teammates is a guy named Nathan who is really smart and really funny and will give you the truth in really unique ways. And we shared this with him and he said, oh, dude, that's totally permitted. I'm like, well, how do you know that? And he's like, well, let me show you. So sure enough, we go and try it, and it does work. And then we went back to our notes and was like, Abian, Miku, like, were we wrong? Did we miss something when we started this research? So we went back and retraced our steps. And we went back and said, okay, AWS, let's ask you one more time. How do we get this action? Let's start with the letter C, invalid, 2 to 64 characters. Again, this should look really familiar. We keep typing, create, okay, it's still not resolving to an action. Throw that wildcard in there, perfect, all right? This resolves to 14 actions. Now here's what's interesting. We removed that wildcard, and it still says 14 actions, okay? This add action button went away, but this message was still the same. And then we start taking off character and character, and we realize we can literally put almost anything we want as long as we don't remove all the characters, and the UI is still telling us this resolves to 14 actions, which clearly it doesn't. So we play around with it some more, and then we finally add a wildcard, and now it resolves to 1. It's like, what is going on with this thing? And then we tried some other things. Casing, it still says casing is case sensitive. We know that's not true. Okay, what if we change this to hex? It doesn't appreciate that, even though we know this works in policies. Let's change it to those question marks. It doesn't think it's correct. What is going on? Why not throw an extra question mark onto the end? What do you think would happen when we did that? The whole thing crashed. Like, the UI literally crashed. It's like, okay, clearly something weird is going on. So then we went through and tried to figure out why is it crashing if it ends with 3 question marks. So we did some manual testing and then realized, you know what, all the cool kids are just pulling up developer tools. So we did that and realized it's actually a regex error. So as we're typing into this field, it's performing regular expression evaluations to say how many actions it evaluates to. And so we found a couple fun scenarios that cause this window to crash, and it makes sense when you look at the regex that it's actually producing and trying to run. So we actually looked at the source code itself to see this makes more sense while it's only updating that one message when an asterisk is present. And so it caused us to lose even more faith in how we were going about asking the UI for answers. So what do we do then? If you can't trust the UI, you can certainly trust the documentation, right? Right? Okay, so what does the documentation say? It's a little bit better, actually. It does say the prefix and action name are case insensitive. Perfect. The UI was wrong about that, but documentation checks out. You can use a wildcard. In number 2 and 3 are 2 different ways you can use the wildcard. But what is suspiciously missing is the question mark, because we know the question mark works. And our friend Nathan told us it works. And Nick Frechette on Twitter says that it works. So why does AWS still, to this day, not say that this is an option? Well, this is where you have to go to other people who have explored this space before us and were so kind to write a blog about it. And there's a SteamPipe blog from 2 or 3 years ago that actually does say multiple questions can be used to match any single character. This is undocumented and seems of little value. If you're big into Google dorking and want to find really small gems like this, look for things like no value, undocumented, or why would somebody do this? Those kinds of blogs and comments lead you to things that someone discovered technically work, but they don't know the value of who in their right mind would do that. And that's usually a really good indicator that you're onto something that has a lot of potential. So now Abian's going to show how we can stack all these things together and hopefully not get crushed in the process as we get into some deeper and deeper obfuscation.
Okay, so now we did all the research, we know what's allowed, what's not allowed. So let's gather all of those and put it all together and see what we can come up with. So the first one, we know that the brackets are optional, so if they're optional, why not just add them? And also we can just add another action just to make it more interesting. We can do reorder properties. That's not really a big thing, but since it's allowed, we're just testing out and we're doing that. We can reorder action array elements, so we can do that as well. We can use action wildcards, and if we take these two, we can have multiple character wildcards and single character wildcard cards, and we know that question marks and asterisk is allowed, so let's add those. We can do random casing, so we can we added the random casing. We can also do Unicode encoding. Now when it comes to Unicode encoding, we can Unicode also the column and everything into the action, but we learned at the beginning that we can put any part of the JSON, we can Unicode encode it, so let's add that. And let's not forget the insignificant white space. And I'm not going to get into all the carriage return stuff, but just white space alone. Now, with just these, a simple policy can look like this, but this is a small policy. What happens if we play with larger policies? Now, there's a few things that we should take a look at when we're dealing with this. So we went over to the documentation for inline policies and managed policies to check if there's limitations. And we can see that there's a limitation from 2,000 to 10,000 characters. So we tested that out. And of course, one character in a JSON, it counted as one. But with Unicode encoding, a single character like letter A will be counted as 6. When written into the console. Also, we can see in green that there's a note, in quote, IAM doesn't count white space when calculating the size of a policy. So we tested that out. We created a policy. We added a bunch of white space into it. And it gave us an error, actually. So the documentation was wrong over here. So it says that it should not have more than 131,000 characters. So if we just go below that number or into that number, we're going to get success, but it's going to show up like this. So in request parameters, normally it will show what was requested, so it will show the full policy that was being requested, but in this case, since it was having oversize, it will just show request parameters too large and omitted true. So it will not give us the information of what was being requested, even though the policy wasn't that long, as we can see over here. Okay, so this CloudTrail logging evasion happens from 102,000 characters to 131,000 characters, and we disclosed this to AWS a few months back, and they're applying the fix on Q4 this year. So,
there's still time to use this trick.
Yeah, you can.
Go for it.
Okay, so besides the normal obfuscation, there's also logical obfuscation. So we know we have principal, action, resource, but what about not principal, not action, and not resource? So this is really interesting. So if we say, for example, effect, allow, and action wildcard, we're actually allowing everything. But what if we do effect, allow, and not action, and we just do a random action? So we're excluding that, but taking everything else. So basically, we're allowing everything else. So where should we, as defenders, look at this? So to the IAM policies, so the service control principle, managed policies, and inline policies. So we can do that via the API, but that will show us just the last request. So it will show us what was being requested at the time. So in a better way, that's looking at the runtime events, but that will show us just the last 5. So it will show if in case someone did a malicious policy first and then it gave 5 more benign ones, we would actually miss that. So it's important to look at the runtime events. But where else does these policies actually show up? These show up, we just covered the IAM part of these. So there's a lot of places where these IAM policies show up. Some of them are STS assume role or get federation token, which is an important one. So that's where we can look at specified events. And in that case, shout out to Ela Dejani for her tool, Cloudtail. You can use her tool to actually just select a few events, and then you can just check the logs of those events and try it out. So you won't need a CM for that. So yeah, now we go over and test this out with get federation token, and we can see we're doing the same thing in 3 different ways. So at the first one, we're doing action allow all. At the second one, we're doing the same thing, but we're actually Unicode encoding the whole JSON. And at the third one, we're just doing a random action. We're just not allowing that random action, so we're allowing everything else. And at the request parameters, as I said earlier, if it's not requested omitted true, or requested too large omitted true, it's gonna show what was being requested. So if you're hitting the CloudTrail logs, it will actually show up like this. Imagine being a blue teamer checking the logs to see what was being happening and what was being requested, and you see something like this. So that's where tool selection actually matters. So we tested this out with the CLI and the PowerShell SDK. We just created the same policy, as we can see, LEMSH, more obfuscation. And if we hit those 2, we can see at the CLI version, it will deobfuscate the carriage return, so it will normalize it and formats it. But at the second one, we can see that it actually it will remain the carriage return. Also, AWS CLI normalized everything. So if you're checking at the logs as Defender to see if there was a malicious policy being requested through the CLI, you will actually miss what was being requested and would miss that what attacker was trying to do and why he was trying to obfuscate things. So it would show up a clear policy of being requested. But in SDK, on the other hand, it will preserve all the obfuscation. So if we also change that with the if we replace the white space, we can also see that the carriage return was also present.
So as Abian showed, tool selection matters both offensively and defensively. And so for each of these building blocks, like I would encourage all of you, whatever tool you're using, like even offensively, if something doesn't work, try it with another tool, because the tools sometimes are being helpful, like AWS CLI is being helpful in removing that obfuscation. But if we're using this to find the obfuscation, we don't want it removed. And so there were several times where we kind of, in our notes, just said, hey, this didn't work. Come back to those notes. The things that didn't work 6 months ago, you know more things 6 months later. Go try it again with another SDK or in the UI, and you'll find different results, which makes it harder to research, but more interesting to know that there are different tools that do behave differently. So with all of this being said, with all the JSON level tricks of encoding and white space and all these things, and then all the logging evasions, and then all the multitude of runtime events where policies are present, and some of those preserve this differently than others, where do defenders go from here? So as defenders, we do this research to make sure that we're building a solution that we're going to open source, that is open source to help defenders. And this is where this is kind of a similar problem to some of the LDAP stuff yesterday. We need our own parser that doesn't fully parse and deserialize the JSON. We want to do that first step without cleaning up any of the insignificant white space, because we actually want to see and measure and know that the insignificant things are present. So we wrote a custom JSON parser, and again, very similar to any parser. This involves taking JSON strings as one big string, tokenizing it into its individual pieces, and then grouping it together as a parse tree or a syntax tree so that we can understand the relationships between all of these tokens. And then as we actually tokenize a policy like this, we can see that we have kind of inline decoding, but we still preserve the raw content. So in this case, the decoded value is allow action, but we can see the actual plain text version is still held there, as well as the exact position, the line, the start, the end, and indexes. And again, this is all important because we're not just interested in what we're visually seeing. We want this to be something that we can measure so that when there are millions of these events, the measurement is something that we can detect and then present that much smaller set of data to human eyes to validate what we're seeing. We also have this was actually kind of interesting because, let me go back real quick. One of the things that can't just be decoded is wildcards. because wildcards is actually truly the absence of data now. If this policy started fully defining I am : PassRole, then this is a loss of information. The attacker intentionally dropped characters out and replaced it with a wildcard, knowing that logically it would resolve to that one value. So in this case, we actually can't just rely on decoding. We have to have additional enrichment. So whenever we see wildcards in the parser, it will automatically check the updated database of all of the all of the actions that AWS supports, which is now like 18,000. They're adding a couple hundred every few months, and it will basically say, hey, this action right here with this hex encoding, so this Unicode syntax, these two single character wildcards, it resolves to all of these actions right here. And this is also a really cool detection opportunity. What if you were able to take a policy, action by action, and say this one action resolves to 16 specific actions? That's a pretty unique capability that we have that's in the tool because of the way we're doing the parsing and the enrichment here. And then lastly, we wanted to make all this as easy to use as possible. So you can just pipe this into the find evil function, which has all of our detections that Abian and I wrote to detect all these really interesting scenarios, and to kind of assign a score, a description, as well as a summary, and to really go ahead and highlight the specific reasons this rule matched, as well as what the characters look like in their content, as well as their decoded values. So I try to make this as easy and as fun to use as possible. So instead of talking about the solution some more, let's show you some demos, and then we'll wrap up with a few key takeaways. Whenever you're doing this kind of research, there's a certain point at which you get so tired and frustrated that you almost lose motivation. That's usually when you have to say, what are we naming this tool and what's the ASCII art? And that's usually the motivation we need to finish it. So we went with a sky theme in SkyScalpel, the idea being it's like a scalpel razor that we can really cut and slice these policies apart and then reassemble them together in really fun ways. So let's take a quick look at one of those obfuscated examples that Abian showed. Is it Lumpsch? I'm probably not saying that right. My apologies. But let's just get the content of that policy. It looks like this. There's one statement. There's a bunch of weird new lines. Now, if we pipe that into our out JSON object, we'll actually see, hey, there was a whole hidden statement here. So there must be some of those weird backspaces that are involved. So now if we go and what we're going to do, pipe it into JQ. No, convert to JSON. We'll use PowerShell's version of that. No, we won't. We're going to use our version of that. We're going to convert to a JSON object and parse it, and we can see this is the content, as well as for every token, the start, the end, the line, etc. So let's slice that up a little bit so we can see it top to bottom, and we'll see we have some obfuscation, some Unicode, some wildcards, etc. Now we're going to go back and say, instead of parsing it as a JSON token, let's do a JSON token enriched. That's going to give us the decoded value for each one of these, as well as some additional context objects that we'll see in just a moment. So this allows us to see the true values that's going to be interpreted, as well as the original values. And even just comparing the difference between these two is a great way to see that there is some obfuscation in play. And now if we pipe it into find evil, we'll see it's doing all that parsing and then running it against all the rules. And so we can kind of slice that to say what's the rule ID, what's the score, what's the reason, the description, and you can very easily see the before and after, as well as the cumulative score for all the individual rules that fired for that specific policy. So again, if you have a large cloud environment, you literally might be seeing thousands of these in runtime logs. Scoop them out of the runtime logs, pipe it into this tool, and it will go through and say, hey, of all the policies, these are the only ones that had hits. Here are the hits. Here are the reasons why this is interesting. You should probably take a look at this, and you can continue your analysis in here. And so this is kind of more of the defensive side of the analysis. So for a lot of people, this might be the only thing that you care about. And if so, we hope it's helpful. But if you're of the more red persuasion, you might like what Abian's going to show.
Okay, so in this other case, we're just going to get a policy that is also written into our tool. And this is just a random policy that we're going to play around. And let's invoke that into our tool, which is invoke SkyScalpel. You can see all the cool ASCII art that shows up when we pipe into it. So over here, we have a full menu of things that we can use. If we go over to the tutorial, it will show us what we can do, what we can load, how it works. So if we do show, it will show up what was the policy that we piped into it and which one are we using. So we're just going to use the obfuscate module first. So we're going to add a bunch of Unicode encoding. We're just pressing a few numbers so we show how much percentage we want to add to Unicode encoding. We do that to white space. So we're adding a bunch of white space as well. We add also to the AWS policy, which we can use as multiple wildcards as well. And if we go all the way back, we can just use single character wildcards and multiple character wildcards. And if we just do show, it will show us what was the policy and what detection score and detection count it has. So if we do find evil, it will give us a full summary of everything that happened. It will show us the score. It will show us the unique events, the unique signals that were triggered. It will show each line what it had and what was the content and the content decoded of that JSON. So if we go back to the menu and we use the deobfuscate module, which deobfuscates everything, and we just put a bunch of wildcards which will randomly run into the menus and deobfuscate everything. We can see that this is the policy that we had over. So it will remove the white space, it will remove the Unicode encoding, and we can see that there was a bunch of Unicode encode left, so we can manually go over. And we can see over here that detection count was 0, so the policy was completely returned into normal. Now, if we go over to the reset and show what we did so far, it will show us a full history of how it started. And we can also, if we don't want all the SCI art or we're just like a recipe, we can just use command line syntax. So it's important to just use this as defender if you want to see what the attacker was doing. You can use this as a blue team, but also you can use the obfuscate module as a red team to obfuscate your policies as well to test it out in your environment. So what are the three main takeaways from this? So we know that JSON obfuscation is not new, but is largely unexplored, so not many people know about it. In context of cloud security, not many people talk about it. Second is it's important to identify and monitor suspectable services, APIs, and data sources, and using well-tested and well-understood tooling. And third is just using SkyScalpel. So if you're a blue teamer, you can use it to deobfuscate policies that you see in your environment. If you see it on the wild and in your environment, you can use SkyScalpel to check what it was being said actually. And if you're a red teamer, you can test it by obfuscating the policies and sending it over to and try and see if your detection actually catches it, or if you can bypass your detection with it. So with that being said, thank you so much for your time. Okay, so this was SkyScalpel. If you have any questions, we're free to reach out, or we can also answer around. We'll be around, or you can ping us on LinkedIn or Twitter or X.
Any brave souls with a question? Awesome. Well, thank you again for your time. It was really fun to be here and present, and we'll be around. Thank you. Follow me there.